Hello! In this video, we are going to prove the following theorem. Let S be a subset of real numbers, and suppose U is an upper bound of S. If U is an element of S, then U is the supremum of S. Okay, now in proving this theorem, we are going to rely on the following fact. Given a subset of real numbers S and a real number U, we have that U is the supremum of S if and only if both 1 and 2 are true. 1 is that for all elements T and S, T is less than or equal to U. In other words, U is an upper bound of S. And second, for all real numbers V, if V is less than U, then there exists an element S and S such that V is less than S. And I'll call this fact lemma star. Okay, now let's get into the proof. To start out, let's give ourselves a subset of real numbers S and a real number U, which is an upper bound of S. From here, we want to show that if U is an element of S, then U is the supremum of S. So since we're trying to prove an if-then, let's suppose that U is an element of S. And our whole goal from here is to show that U is the supremum of S. And to show that, we're going to apply lemma star. Now, in applying this lemma, we're going to take S to be S and U to be U. And to show that U is the supremum of S, we're going to show that both condition 1 and condition 2 are satisfied. Well, we already know that condition 1 is satisfied because condition 1 is the same thing as what it means by definition for U to be an upper bound of S, right? And we know that U is an upper bound of S. So all that's left to do is show that 2 holds. And we're trying to prove the same about every real number, so give me an arbitrary real number. I'll call it V. And with this arbitrary real number V, we want to prove if this is true, then this is true. So let's suppose that V is less than U. And from here, we want to show that there exists an element S in S such that V is less than S. Well, if we take S to be U, then we're all good. Right? Because if we take S to be U, well, we see that U is an element of S, right? That's what we have right here. And we have that V is less than U. That's what we have here. So yes, there exists an element S in S such that V is less than S, namely U. So this is true. And so putting this together, we gave ourselves an arbitrary real number V. And from the assumption that V is less than U, we found that there exists an element S in S such that V is less than S. So this means that we have proven that 2 is true. So we have that both 1 and 2 hold, which means by lemma star, U is the supremum of S. And that is exactly what we wanted to show. So this completes the proof. And so yeah, that's pretty much it for this video.